In this video, I'm going to be modeling for you and discussing with you patterns of addition. So first, let's all get on the same page about what patterns are. Patterns are things that happen over and over again. So you're going to see something many times, and it's going to let you know that there's a pattern there. And you can use it to predict when you're given an unknown example of something. You can use what you've already seen happen over and over again. So let's talk about our first kind of pattern, which is things with even and odd numbers. So let's be reminded what even numbers are. Even numbers are numbers that can make equal groups. So let me give you a couple of examples here. So I have the number 2. If I make 2 dots, these can make an equal group. They've grouped up, nothing left over, it's an equal group. Let me give you another example of 6. If I make 6 dots, I can either look at it like this, that I could pair them up here, or that I have a group of 3, everything's equal. So I can either pair them up, or I can just try to make 2 equal groups. So it's either groups of 2 or 2 equal groups. Now, an odd number is the opposite. It cannot do that. So let me give you a couple examples there for you to see. 3 dots here. I cannot make equal groups. If I pair them up here, this one's going to be left over. Or if I make a group here, this one's left out. I have a group of 2 and a group of 1. It's not going to work. That is an odd number. Another example here, let me draw 7 dots for you. I could either say, oh, I have a group of 4 and a group of 3. That's not going to work out. Or let me just pair them up and say, oh, there's that one that's odd. It's out. It doesn't have anything to pair up with. So now that we see even and odd, we can see patterns for when we add even and odd numbers together. So let's look at a few examples here. If I take an even plus an even number, so let me take 2 examples here. I have 4, which I'm pretty sure is even, and I have 6, and I'm pretty sure that's even, but let me double check. So 4 is even, because right there, nothing left over. 6 is even, because it has nothing left over. Now, when I join them together for addition, still, oops, that's right there, nothing's left over. So it's 2, 4, 6, 8, 10. 10, then, when I've joined together, 4 and 6 is an even number. So even plus even is even. Odd numbers. Let me give you a couple examples there. So let me take 3 plus 5. Pretty sure they're odd, but I'll show you. Odd because it can't make those equal groups. This is odd because it can't make those equal groups. But look, when I join them, guess what this odd one and that one is going to do? They're going to join together. So now it's even because 2, 4, 6, 8. Everything has a pair. It's all in equal groups now. So odd plus odd is even though that sounds a little strange. Now let's look at even plus odd, or you could flip it and say odd plus even, because we can do that flipping in addition. So let me take an even number. I'll take 4. 1, 2, 3, 4. It's even. And let me add an odd number. I'll do 7. So we see 7 is an odd number, because it has that odd one there that can't get matched up. When I join them together, this odd one has nothing to join with still. There's nothing here for it. So 2, 4, 6, 8, 10, 11, then, when I join, is an odd number. So even plus an odd is an odd number. So, well, the way I like to look at it is when the 2 add-ins are the same type of number, it's going to be an even sum. And when the 2 add-ins are a different type of number, it's going to be an odd sum. So that's what I like to remember. So this is one type of pattern you will notice in addition. Now, let me show you some patterns on the addition chart. And for this, it's also about explaining it. So let me zoom this in a little bit for you so that you can kind of see the chart a little bit better. All right, just as a reminder for what the addition chart is, these are all of our add-ins up here. These are the add-ins, and all this white space is the sums. So the way you read an addition chart is, if I'm going to do 2 plus 4, I'm going to meet them, and the sum is 6. Or if I'm going to do 4 plus 1, I'm going to meet them, and the sum is 5. So that's how the addition chart works. Now let's look at some patterns here. You'll notice when you look at the addition chart, when I go vertically, the sums are increasing by 1 every single time. It's like I'm counting. Okay, well, the reason that works is this add-end is going to stay the same the whole time. And only this one add-end is increasing by 1, which means it's contributing an extra 1 to the sum every time. So since only one add-end is changing, the sum is going to change by 1. Every single time. And you can see that same pattern when you go horizontally. It's just a different add end is staying the same. Here, if I go horizontally, this add end is going to stay the same, but this one is going to increase by 1, which means my sum is going to increase by 1 because only one add end is changing. So if one add end is increasing by 1, then the sum will increase by 1. And you can do the same thing for subtraction when I go horizontally or vertically this way. So we see that same pattern when we're going horizontally and when we're going vertically because it's only one add end is changing. Either it's increasing by one add end or decreasing by one add end. Either way works, but it's one add end changing, so the sum will change by 1. Now, when we look diagonally, 1, 3, 5, 7, 9, I notice 4, 6, 8, 10, that my sum is changing by 2. Well, we get our sum by joining addends, so there's got to be some kind of pattern with the addends. So let me look at that. Okay, so if I look here at 2, when I go, this 2 is made of 2 and 0. And if I go diagonally to 4, I'm now moving this 2 to 3 and this 0 to 1. Both of my addends have changed. Both of my addends increased by 1. They're both contributing to the sum. That means the sum is going to increase by 2. When two addends are increasing by 1, the sum is actually going to increase by 2 because both of them are giving something. So I hope that makes sense to you. Diagonally, this way is increasing by 2. Obviously, if you go backwards, it would be decreasing by 2 because both addends are taking 1 away. They're decreasing by 1, but it's both of them. So the sum is going to decrease by 2. Let's look at one more pattern, and this is the trickiest one to see just because of the way you have to look for it. So here, I notice my sum is not changing at all. I have 5, 5, 5, 5, 5, 6, 6, 6, 6, 6, 6, 6, 7, 7, 7, 7, 7. So it's got to be something with the addends. The sum comes from its addends. So let me look at that here. So if I look at these 5s here, okay, this 5 is coming from 5 and 0. But then to get this 5, it's coming from 4 and 1. So I notice that this addend has decreased by 1. This addend increased by 1. Let me look at that again. Let me look at this 4. This 4 is coming from 2 and 2. This addend has now decreased again by 1, and this addend has now increased by 1. So I'm noticing for my sum to stay the same, one addend is decreasing by 1, one addend is increasing by 1. It's almost as if this addend is giving away to this addend. So it's not gaining anything. It's just moving it from one addend to the other. If I look at it this way, it's the same idea. It's just a different addend is gaining and losing. So here, this would be the addend that is gaining, whereas these would be the addends that are losing. But it's really just giving it. It's like they're just sharing them back and forth. So nothing is being lost or gained. It's just going from one addend to the other. So pay attention to these patterns because they can help you predict what's going to happen and why things happen. So there's the patterns on the chart, and then there's also the patterns with even and odd numbers.